Hello, everyone, and welcome to the PAPERI Bright Minds Series, organized by the Pan-African PGS Education and Research Initiative. My name is Rose Nasser, a TA in the Faculty of Medicine in Ain Shams University in Egypt, and I will be your moderator for today's session. On behalf of our founder and chair, Dr. Wafa Rashid, and the entire PAPERI team, we are delighted to have you with us as we celebrate the International Women's Day and honor outstanding women leaders in genetics and genomics. This special session is dedicated to recognize excellence, leadership, and impact, and to inspire the next generation of scientists across Africa and beyond. Today, we are privileged to welcome our distinguished guest, Mrs. Chioma Oselu. I hope I'm pronouncing it correctly.
Chioma.
Chioma Oselu. Okay.
Yes. Yeah, thank you.
Okay. So, Chioma Oselu is a PhD student in bioinformatics at Covenant University in Nigeria. Her research focuses on building reproducible pipelines for polygenic risk score, PRS, analysis to improve genetic risk prediction across African populations. She is a recipient of the L'Oréal UNESCO for Women in Science 2025 award in Sub-Saharan Africa. She is also recognized for her scientific contribution of her doctoral research. Chioma currently serves as a president of the ISCB Student Council Regional Student Group Nigeria, where she leads initiatives that strengthen bioinformatics training, mentorship, and community building across Nigeria. She is passionate about advancing inclusive genomic research and capacity building in Africa and regularly shares practical bioinformatics resources to support beginners and emerging scientists. We are truly honored to have her with us today. Mrs. Chioma Oselu, thank you very much for joining us and welcome to the PAPERI Bright Mind series. We will begin with a conversation about your career path, followed by your research, leadership, and vision for the future. Okay, let us begin. So can you take us back to the moment you received the news about being named 2025 L'Oréal UNESCO for Women in Science laureate? And what did that recognition mean to you, professionally and personally?
Yes, when I received the news, my reaction was actually quite quiet. I think I was in the office that day. I was battling with one of my scripts, our scripts, and I got the call from one of the L'Oreal UNESCO community representative, and she was like, "Oh, am I speaking with Chioma?" And she, gave me the news. I just paused and stopped what I was doing and fell on my knees. It was like, I think I have a compensation now after all these years of research and back and forth and not knowing if what you're doing is actually, meaningful. So I was like that tend to make you pause more than celebrate. Like you just pause and you're like, you want to soak it all, you want to, take it all in. And okay. And I was not the only one in the office that day. I had my colleague, and she was just looking at me like, "Are you sure you're all right?" And I couldn't like I couldn't form
Express?
words to capture that. So for me, the recognition felt less like a personal milestone. It was more like a validation of the kinds of questions I've been working on, particularly around representation in genomics research and how computational tools behave when applied to diverse populations. It also reminded me that, science is rarely an individual effort. Behind every recognition is a network of mentors, collaborators, training communities, people who help shape like the thinking. So professionally, it's made me realize something important. When recognition comes, it expands your responsibility. It means now you're thinking more intentionally about mentorship. How do I get people to, see that opportunities like this exist? Capacity building and contributing to the entire research ecosystem around you. Yeah.
Right, very nice. We learned that you learned your journey with a background in biochemistry, and then you
Yes.
transitioned into bioinformatics and computational biology. So, what are some of the key moments that shaped this path?
So, my academic foundation, yes, was in biochemistry. Um, for my first degree and second degree, I studied, for my first degree, I studied neurotoxicity. For my second degree, I studied toxicology of plants. Basically, I compared um, two different kinds of pears, the Persea americana, that's avocado pear, and then Dacroides agilis, which is the African pear. So I was trying to see, compare the phytochemical constituents and the toxicological properties. So me starting from biochemistry was an excellent thing for my journey because I initially approached biological problems from a molecular and experimental perspective. So, but at some point, I became increasingly aware that many biological questions were becoming computational problems. So, genomics in particular, lots of data sets, enormous data sets are being generated, and to understand them, we need statistical and computational tools. So starting out in biochemistry really shaped that for me. I realized that if I really wanted to study biological systems at a population scale, things like, disease risk across populations, I needed to become comfortable working with data. So the transition into bioinformatics was partly curiosity and necessity. So biochemistry to summarize it, biochemistry helped me to understand how biological systems function, while bioinformatics allowed me to explore how those systems behave across thousands of individuals at once at a time. Yes.
Yeah, okay. So, looking back, what were some of the most challenging periods in your journey, and what helped you persist through them?
Well, um, quite a number. So one of the most challenging aspects was entering a field that is inherently interdisciplinary. When you talk about bioinformatics, it means that you have to learn, for those not coming from biology, you have to learn biology. You have to understand the basic biological concepts, including molecular biology. It also means that you have to learn statistics. You have to, because at some point during your analysis, you need to understand the significance. It just because you got this result doesn't mean that it should be applicable. You need to understand the level of significance. That's where statistics comes in. So at some point, you also still need to understand computer sciences, machine learning, and all of that. So it was a lot because bioinformatics sits at the intersection of all of this. So if you come from one background, you have to build competence in the others over time. So there are periods where those technical learning curve felt steep. Like sometimes the code will not just be running, and you're wondering like, okay, how do I fix this? And even though you've taken some trainings and some classes over time, sometimes you would still get stuck. So what helped was learning to approach the field gradually. So instead of trying to master everything at once, I focused on solving specific problems and building knowledge around them. So I like to learn in layers, and it's something I always try to talk to my mentees about. When you have a problem in when you have a research question or a task to do in bioinformatics, you have to split it into layers just so that you can think clearly. Yes, we have AI tools to help us, code better, but the thinking is still the responsibility of the scientist. You need to think properly on how to execute each task, and you need to know how they come, the flow from one point to another. So another thing is community. You cannot Research never works in isolation. So being part of scientific networks where questions are welcomed are like things that really made a big difference. So yeah, especially in a field like computational biology that evolves like quickly, you need a community so that you are being informed about those advancements.
Yeah, I see. Sure. Okay. Very nice. So your current research focuses on polygenic risk scores and cancer risk
Yeah.
prediction for African populations specifically. So why is this work specifically important in the African context?
So Uh, I think we should start from what polygenic risk scores is. To put it simply, polygenic risk score it gives an estimate of an individual's susceptibility to a disease. So most of these PRS models today were actually built using data sets that are heavily dominated by European ancestry populations. So
Mm.
as a result, they tend to perform best in the populations they were trained on, right? So
Of course.
Africa presents a different picture. So the continent has we have the highest human genetic diversity in the world. So I know that is no news to anybody. So now that diversity carries a lot of information about how genetic variants interact and how disease risk is structured across populations. So when predictive models are built elsewhere and then applied to African populations, they often perform poorly. And so it's not because the science is wrong, but because the models never trained on the full range of human genetic variation. So, from a research perspective, this is a limitation, and importantly, it's an opportunity. So, studying disease risk in populations with high genetic diversity can help us to understand better how these genetic variants behave across, different backgrounds. So in some cases, it can even help you to refine those signals that are harder to disentangle in some genetically homogeneous populations. So the goal now is we're not saying just include African data as an afterthought. So it is to recognize that studying diverse populations improves science for everyone. So I think I would say to improve equitable science, you need equitable evidence. So you need that has to just be integrated. Yes.
Yeah, of course, you're right. Yeah. Okay, thank you. So many predictive models do not generalize well to underrepresented populations, like African
Yeah.
populations. So from your perspective, what needs to change in global genomic research to address this gap in more
So
details?
for me, I would say three different shifts.
Mhm.
Um For example, one thing that needs to change is how we think about diversity, which I already spoke a bit about in the previous question. So we need to change how we think about diversity in genomics research. For a long time, the conversation has been on adding more diverse data sets, which is important. But another aspect of diversity, and I would say this from a development point of view, another aspect is diversity should shape how methods are designed from beginning. So now, in polygenic risk scores, we have I don't know, I usually call it different flavors of methods for calculating polygenic risk scores. So, for single ancestry methods, we have quite a handful of them. We have precise, we have LDPRED 2, PRSS, and all of that. And then for multi ancestry, which is what I focus on, we have that one has like a broad statistical family for calculating polygenic risk scores. And now, when I talk about the methods, how diversity should be integrated into methods from the beginning, I'm talking about three things. So first, broader representation in genomic studies. So um, without methods that consider this diversity, we cannot properly evaluate models that behave across that we cannot properly evaluate how models behave across populations. These methods have different ways they handle data. They have different, should I call them assumptions? Some of them are Bayesian, some of them use transfer learning approaches, some of them use regularized regression approaches. So that needs like the in the method development stage, diversity also needs to be considered. Secondly, leadership. So leadership from scientists working, and this is something I would give credit to PAPERI for. I usually see PAPERI's posts on across social media platforms, specifically LinkedIn, and Dr. Wafa's post. She usually talks about leadership in this space, and I think it's something that we should actually look into. So leadership from scientists working in these regions, the regions where these populations live. Local researchers, they often understand the population structure, they understand the health system, they understand the research context in ways that are difficult to capture from a distance, right? And that's something. And then the third one would be um uh broader representation in genomic studies, which is diversity in data sets, like what we already know. And I think this is something that should be taken note of. When you begin working with highly diverse populations, uh, according to literature, those papers, you'd see the change in accuracy. And for polygenic risk scores, some of the accuracy metrics that matter in the field is AUC. We have the predictive R square. We have the NKR square and the likes. Yeah.
Yeah, okay, thank you so much. So, how do you see your work contributing to more equitable and inclusive healthcare outcomes in the long term?
As I mentioned earlier, I'm involved in the method development aspect of polygenic risk scores. So my work focuses on benchmarking. So I'm basically working on evaluating how predictive models behave and how to improve the predictive accuracy of models in African populations specifically. So the thing is, rather than assuming a model works everywhere, we need to understand the conditions under which it performs reliably and where it begins to break down. So I would say that PRS research has it's moved from whether PRS can actually predict scores, because yeah, as we know, or um currently, PRS is already being integrated in clinical risk models. So it's not, the question is not can it predict can it predict disease? It's can it predict well for everyone, right? And um this is important. Benchmarking is a very important aspect of that, because benchmarking is a key determinant factor of whether a score can be trusted. And that's one challenge we're having in polygenic risk scores now, the clinical translation of these scores. So benchmarking helps us to trust a score better. So if those models are not carefully accessed, across populations, there's a risk that the benefits of the medicine, of genomic medicine or precision medicine would remain unevenly distributed. That's benefiting some populations better than the rest, and we don't want that. So in the long term, I would say that I hope this work contributes to building predictive tools that are not only accurate, but also broadly applicable across different populations.
Yeah, very nice. All right, so we're gonna move to another section concerning open science, mentorship, and capacity building. So the first
Yeah.
question is, you are actively involved in open source initiatives such as
Mhm.
Boxes DB and in mentoring and engaging researchers. So why is open science important to you?
So open science is relevant to me and is important to me because it changes who can participate in research. So when I first started writing on LinkedIn, one thing I usually encourage my followers and my community to do is to try and contribute to open source projects. So there's something that happens in this space in bioinformatics. So this is what happens, right? You're a fresh graduate, or you're still in school, and you want to obviously you're learning. At the same time, you need a financial way of sustaining yourself while you learn, because when you're learning, if you don't have a way of sustaining yourself, it distracts you among other factors, right? So one way to in the field, most times before you to most of the job descriptions, they ask you if you have a master's degree in bioinformatics or a relevant field related, or they ask you if you have a PhD. And PhD is something I'm seeing like common now in JDs. So now the thing is, how do you apply for such jobs? How do you have confidence to apply for such jobs if you don't have experience? So that's where open source comes in. Open source gives beginners, early career researchers the opportunity to contribute without experience. Open source gives you that experience, like it helps you to have that experience. And now sometimes open source doesn't always have to be a volunteering work. It doesn't always have to be a freelance something that you do for free. Although volunteering also has its own perks, but most times sometimes open source doesn't have to be something you do for free. And then that's where programs like Outreachy, Google Summer of Code, and all those open source platforms come in. Now I'll start from Outreachy, and I'll talk about Outreachy alone. So because of our time, so Outreachy is a program that is tailored to basically people who are underrepresented, or who face systemic bias, discrimination in the technical industry where they are from. So with Outreachy, it provides beginners, especially women and some specific gender groups, 3 months to do internship, and then they pay you a good amount of money. So that's one way to learn and earn in the space. So you're learning, you're earning, you're getting experience, and then you are contributing to science from like in the international space. You're seeing how science is being done. So one of the projects I contributed to, I was an Outreachy intern. I interned with Outreachy in 2023. So one of the projects I contributed to is the bioconductor BoxitDB project. So BoxitDB is a community-driven database that curates microbial signatures from microbiome studies. So the idea is that researchers around the world collaboratively curate, and then they organize these published microbiome results so they become searchable and then reusable. So BoxitDB gave me the space to connect with mentors and top researchers in the microbiome space. I met excellent researchers like Professor Levi Waldron, Dr. Svetlana Perovic, Dr. Chloe Mezai. So over time, I got closer to them, and they became my mentors. So open source gives you that opportunity to interact one-on-one with top researchers in the space. So
Mhm.
imagine having to, if you have questions about something, that mentor is only a DM away. So unlike not being in open source, and then you have to look for them on LinkedIn, and then they might not, or they might reply to your message. So open source gives you that opportunity. So what I found very meaningful about work is how distributed the contributions are in the BoxitDB. Scientists, students, curators from different countries, they all contribute to building a shared scientific resource. So last but not the least, so for researchers in low resource settings, open source is non-negotiable. It is transformative, and I have written a lot about it. I think sometimes I tell myself, am I just writing about this too much, or there's still someone out there who doesn't know about open source? So access to open data sets, not just the tools, data sets, collaborative platforms that allow people to, engage in the global research conversations, even when the local infrastructure is limited. So that there's a lot I can say about open source, but let's stop here. Yes.
All right. Thank you so much. And I think even if we don't have time, if you want to write their names in the chat box so we can share them with our audience. You mentioned
Okay.
one, but like you can like write their names, and I think they'll look them up.
Yeah, Outreachy. Let me see if I can do that.
All right. Take your
Yeah,
time.
yes. There's Outreachy, there's Gstock, that's Google Summer of Code, and I think there's one There's one with in the Indian space, Girl Script Summer of Code is GSOC, but is with a double S. So there's also I have a link on my GitHub that is tailored to open source opportunities in bioinformatics. So maybe I'll just share that link. Um, Currently it has about 12 stars, 12 or 10 stars on GitHub. So I'll just share that so that
All right.
let me
If you
see
can
where.
find it
Yeah,
quickly, it's fine. If you can't, you can send it after the meeting as you like.
yeah, sure. I've found it actually. Let me just get the
Okay.
link.
Okay.
Yeah.
Very nice.
So it's titled Open Source Bioinformatics Projects. So it's a curated list of both paid and unpaid open source opportunities, projects,
Mm.
resources for bioinformatics, early career researchers and beginners to gain experience and build portfolios and grow in the space.
Mhm.
So I just share the link.
All right.
Yeah.
Thank you so much. All right. So, what have you learned from mentoring students and early career researchers, particularly those from low resource settings?
Yes, so one observation is that curiosity. Yes,
Mhm.
is that there's something I've noticed. Curiosity is like, should I say, widely distributed. So it's not like they don't have the talent. It's not like they are not curious. It's not like they are not putting in the work. The one limitation is access. So access to tools, access to mentorship, access to infrastructure, access to research environments. It is limited in this in low resource settings. You can see someone who has who has taken a course, done a training, but then they don't have the resources to actually properly execute what they've been taught. So that's a significant limitation. And then when early career researchers are given access to the right resources and guidance, their ability to grow quickly is remarkable. That's something I've noticed. So mentorship, in my experience, is less about directing someone's path. For me, it goes beyond that. It involves helping them to build confidence in their ability to ask and pursue scientific questions more independently. Yes.
Yeah. Okay. Thank you so much. So now we're gonna move to another section focusing on women
Yeah.
in science and leadership. As a woman scientist receiving a global recognition, what message would you like to share with young African women considering careers in STEM?
Okay, so one thing I would like to say is STEM doesn't belong to special people.
Mhm.
STEM is not for special people. STEM is for people who are curious, who are never tired of asking questions. So you have to believe that you belong in the room. You have to believe that your perspectives, your questions are relevant in the scientific space. So scientific careers actually develop. Another thing I'll say is scientific careers develop gradually. So you don't expect it's like a step. You climb one, you climb the next, then you move, then you move, then you move. You don't know, you cannot see like it's like in a dark room. You cannot see the 20th step until you actually climb the first one, and then you move gradually. Your path keeps getting illuminated with by illumination I mean like resources, opportunities, mentorship, and all of that. So you need to take the first step, and then you need to give yourself that grace to understand that scientific careers develop gradually. So you just have to keep staying engaged, keep asking questions that genuinely interest you. And then the last thing I would say is community. I think I've mentioned community so many times
It's
in
true.
this
Yeah.
call. Yes, you researchers can't grow in isolation. I'm saying this because a handful of the opportunities I've gotten today are as a result of the communities I'm in. by communities, I mean LinkedIn, across social media platforms, because you're just one person. You can't really like search all the opportunities in the space alone. That's why you need to be in a community where people are like-minded people like you are sharing opportunities, talking about these opportunities, posting links about these opportunities so that you see them, you engage, you ask questions, you apply. So it is important to find communities that support your growth. Like you just have to be in communities. I'm not saying communities, like different
Yes.
communities, because sometimes science can feel isolating. But when you're in a community, like all those collaborative networks, it makes the journey much more sustainable. Yeah.
All right. Yeah. I think you kind of answered my next question already in this one because it was about the community. So maybe you can tell us how African institutions and initiatives can better support young scientists and transitioning into computational and genomics driven research.
Okay, so one observation I've made over time is that many young scientists in Africa are able to access short-term training programs, but
Mhm.
one thing they lack is the continuity after the training ends. So you see
Mm.
a young student attend a workshop about how to use HPC, right? So you attended a workshop on how to use HPC and they taught you like the basics, the foundational concepts, practical. You even got to the practical stage where you learned how to use HPC. So how do you sustain that if you don't have HPC? You'd forget it if you don't. Yes. So
Yes.
now, yes. So now, back to what I said. They often lack continuity after that training ends. So
Mhm.
when you return to an environment where it is difficult to apply those skills, it means you never really learned it, because one thing about learning is in applying. When you learn, you know it. When you apply, you master it. So you have to apply. So the question for institutions now is not you. We're not saying train scientists. We're saying train scientists, but don't stop there, right? We're saying create environments where they can keep practicing and developing those skills. So now this could include things like sustained mentorship programs, um, um, collaborative research groups that include early career researchers, access to shared computational infrastructure. There's also small research grants that allow young scientists to pursue independent questions. And then this is one of the critical backbone of ISCB. So ISCB RSG Nigeria is one of the communities that I'm privileged to serve as the president. So the full name is International Society for Computational Biology, Regional Student Group Nigeria. So at ISCB, our main focus is to improve the landscape and the capacity building, the training, the skills of researchers in Nigeria in
Mhm.
bioinformatics, computational biology, and genomics. So one thing that is very important to us is this sustainability after training. We are currently integrating different protocols and steps to help them to create an environment that helps them keep practicing skills. So currently we're organizing our first workshop, and then from that first workshop, we are going to provide free HPC of space and HPC space and resources to a selected few so that they can keep going. So we have a collaboration with some communities to do that. So communities and individuals, sorry, to do that. So this is something I feel like institutions in Africa can do. It's good. It's a very beautiful time to be alive. We have a number of communities like Genomic, Helix Biogen Institute, we have AceGid, we have Hack Bio, we have a whole range of communities in Nigeria contributing to to most of these efforts. But now we're talking about sustainability after learning. How do they sustain themselves? We also have communities contributing to this sustainability aspect that they give how do I explain this? They run programs that give people free laptops, scholarships, free laptops, and all of that. So these are things that I feel like we can integrate. So another important aspect is collaboration. Bioinformatics
Yeah.
involve, like I said, biology, statistics, and all of that. So institutions should create spaces where these disciplines interact regularly. So when they do that, innovation tends to flow naturally. So the goal, we're not just producing trained individuals, we are building research ecosystems where those trained individuals can thrive. Yeah.
Yeah. Okay. Thank you so
I
much.
feel, yeah, I feel like I spoke a lot about that
No, no,
part.
no, 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 not at all.
Yeah.
It's very nice, very insightful.
Yeah.
We're gonna have our last set of questions. They're
Okay.
mainly about what's ahead of us. So, what excites you most about the next phase of your research and professional journey?
Okay. So many things actually excite me. Where should I start? It's a lot. So, but let me just summarize that. So what excites me most is the rapid evolution of computational genomics. So
Mhm.
we are seeing increasing integration between artificial intelligence, genomics, large scale population data sets. So at the same time, African genomics research is growing. We would agree that is growing. So with more scientists across the continent contributing to both data generation, methodological development. So that combination creates interesting opportunities for innovation. So these are some of the things, just to name a few. Yeah.
Yeah. All right. And how would you like your work to be remembered or to shape the next generation of African scientists?
Yeah, sorry, I just quickly had to connect my laptop. Please, you'd give me a minute. Just
Right.
a
Yeah.
minute.
Sure. Sure. Take your time.
Yes, I'm back.
Hi. Welcome back.
Yeah, I
All right.
apologize for that.
No, no, it's fine. Of
Um,
course.
I actually thought I plugged it in, but turns out that I did not switch on
Yeah.
the
Okay. I see.
sockets. Yeah,
Yeah.
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 So
Okay.
yeah, what was
Mhm.
your question? Sorry.
Yeah. So, how would you like your work to be remembered and to shape the next generation of African scientists?
So if I think about, the question is about legacy. So
Mhm.
if I think about legacy, for me it comes more it for me it's less about individual achievements, and it comes more in terms of contribution in the research culture. So I would like my work in benchmarking to demonstrate that scientists based in Africa can actually contribute. And most times one would assume that it's just data sets that we can contribute. So for me, I would like my work to help to demonstrate that scientists based in Africa can contribute beyond data. We can also contribute methods. We can contribute frameworks. We can contribute ideas that shape global research. So in fields like genomics and computational biology, methodological innovation, it determines how research progresses. So I hope that future African scientists feel confident developing their own tools. They feel confident questioning existing models, and they feel confident proposing new technologies, new approaches. So if my work can create an environment where young researchers feel empowered to ask those ambitious questions and then to pursue them seriously, that would be meaningful for me. So because ultimately scientific progress depends on each generation, pushing the boundaries a little bit further than the previous one. Yes.
All right, very nice. And finally, what advice would you give to someone currently feeling stuck in their scientific journey?
That's normal. Welcome to my world.
Yeah, I
That's
mean, we all
normal.
feel
If
stuck at some
yeah,
point. Yeah.
yeah, if you're doing science, it's normal to feel stuck. You just have to sign up for it. Like, it's not unusual. So feeling stuck is not unusual in science. So
Mhm.
research doesn't go in a straight line. It's not linear. So there are periods of uncertainty. You know, I started this conversation with uh you asked me a question of how I felt when I got the L'Oreal UNESCO call, and
Yeah.
I said the answer with a validation of everything that I've done, like a sort of validation.
Yes.
So there are sometimes that you're uncertain that what am I even doing? Am I really doing something that is relevant, globally? So, and this usually happens when you're learning something new, like, or approaching a complex problem. So feeling stuck is not unusual. So my advice would be stay curious, for those times, seek perspective from mentors, people who have gone ahead of you, or your peers even. So focus on making steady progress instead of immediate breakthroughs. So don't compare your journey with others. Don't do that. You're only going to hurt your mental health. So asking better questions. Sometimes the most productive step forward is asking a better question. So, um, not to take so much of our time, I would like to share one story briefly. When I decided to make a switch from biochemistry to bioinformatics, it was not something I was not sure about it. I had to bet on myself. It was a risk, right? And it was a very big risk because I mean, it's not like I didn't know what I was doing in biochemistry. I finished as the best graduating student in my set in the entire university. And leaving biochemistry, something that I was already used to go into bioinformatics. And then in my university, bioinformatics is in the computer science department. So it's like I didn't have like the only thing I knew in computer science was how to use Microsoft Word, Microsoft Excel, PowerPoint, and all of that. I didn't really know like the uh the the inside, should I call it the inside life of computer science and how it operates. So it was a very big risk, but I had to bet on myself. So you have to learn to bet on yourself. And then some of my mentors were against it, right? Even my mom, she was scared. I had some of my loved ones, they were scared for me, but you just have to take it. And
Mhm.
this is fast forward to almost 11 years later. And this is I think 9 years, sorry, 9 years later, and I'm here. So I guess I made the right decision, right? Or we'll find out. Yeah.
Yeah.
Thank
All
you.
right. Okay.
Yeah.
So yeah, thank you so much, Mrs. Chioma Oselu. Thank you for sharing your journey with us, insights and wisdom. On behalf of Papery, we sincerely thank you for taking the time to be part of this special International Women's Day celebration. So before we close, would you like to share a final message with our audience?
Yeah, I think I already I think I already shared the final message. Just you have to bet on yourself, put yourself out there, because if you don't bet on like you have to first give yourself that validation. You don't wait till the world gives you the validation. You have to prove and show yourself that you're up to the task. And I think from there you start making waves, but gradually. Yeah.
Yeah. All right. Thank you. Thank you for the very inspiring and powerful words. So, to our audience, thank you for joining us today and for being part of this important celebration. We encourage you to continue following Paper's programs and initiatives as we work together to advance genetics, genomics, and scientific leadership across Africa. Please stay connected with us through our platforms and join us for our future editions of the Bright Mind series. Once again, thank you for our guest, thank you for our community, and happy International Women's Day.
Happy
you.
International Women's Day. Thank you so
Yeah,
much.
thank you. We wish you all success and inspiration, and goodbye, and see you soon.